Dear students, greetings. So in this video lecture, we are going to discuss about Ethernet standards in Unit 2, classroom discussion topic 18. Okay. So in this video lecture, we are going to discuss about Ethernet standards in Unit 2 topic, classroom discussion topic. It is week 6, lecture 3. Okay. So after completion of this lecture, student will be able to identify the delay of the data transmission in different types of Ethernet cables. So in this video lecture, we are going to discuss about Ethernet standards and different types of Ethernet cable. After discussion of those topics, the student will be able to identify the time taken for data transmission in different cables, how to calculate and how to identify the delay of the particular cable. Okay. IEEE standards. In Ethernet standards in 1985, Computer Society of IEEE started a project called Project 802. So what happened in world level, IEEE, like Institute of Electrical and Electronics Engineering, with under the IEEE Computer Society, they are set standards to enable intercommunication among equipment from variety of manufacturers. So they are decided some standards for computer networking. That project is called like Project 802. So in case if Ethernet cable means, we can say the standard number is 802.3. Okay. So wherever we are using IEEE 802.3 means that is wired network, wired LAN. Okay. So like that, they are defined the standards for internet networking. No, but IEEE subdivided the data link layer into two layers. Okay, so what are the layers? One is for logical link control layer. So this logical link control layer will consider for controlling the data, and medium access control layer, MAC layer. So this is for access control. Okay, access control. This is for flow control. So we know already the data link layer is have the responsibility of flow control and access control. So for these controls, the IEEE is divided into two subcategories. Okay. So in that example, high level data link control protocol. So what is this protocol? This protocol is bit oriented protocol for communication over point to point or multi point links. Okay. So this protocol, how it is working based on LLC or based on MAC. So LLC is a different format is there, MAC is have different format is there, but HLC have the common points. Okay. So most common protocol for point to point protocol, triple P. You just remember that point to point protocol example is point to point protocol, triple P. Okay, so it is based on the byte oriented protocol. So already we are discussed about bit oriented and byte oriented protocol. Bit oriented means we are adding extra 1 bit for identifying the flow control. Here we are adding 1 byte like 8 bits in the frames, that is considered the byte oriented protocol. Okay. So that is a two sub layers are there, you just remember it, logical link control layers and medium access control layer. These two layers are, there is no separate layers in the OSI model. Okay, in OSI model data link layer only is there, but the IEEE is split according to the work, it is two sub layers. Media access control supplier provides different protocol for different LANs. Okay, so different protocol is there for medium access control. But in media access control have different protocols based on the access the medium. Okay, so example is CSMA bar CD. Carrier sends multiple access. Okay, so carrier sends multiple access. This name CD means collision detection. So this protocol is example for the medium access control layer protocols. Okay, so this protocol used for token ring topologies. Okay, the token bus or token ring topology. This protocol is used in the data link layer. See here, this is the diagrammatic representation. So this is the OSI layer. We know that physical layer, data link layer, and upper layers, network, transport, all other layers. So here in this particular topic, we are going to discuss about only data link layers. So the data link layer is split into link layer control. Okay, so previous slide we are discussed link layer control protocol. Okay, link layer control LLC layer and MAC layer media access control. Okay, so here in media access Ethernet topology, token ring topology, token bus topology is there, but link layer is only flow control. Okay, so this is for access control. So see here, this is for link layer control protocol. In link layer control protocol, there is a destination address, source address, control will be there, and upper layer data will be there. Okay, but in MAC layer, MAC header will be there for media access control, which protocol it is used and how it will be accessed the medium. So those information will be there, and make payload will be there. Payload means again the entire link layer control data will be there, and FCS will be there. Okay, so when you are seeing the HTLC frame, addresses are there. So these addresses, destination address, source address, and control will be there according to link layer protocol, and the remaining entire thing will be there like upper layer data, then FCS will be there. Okay, this is a comparison between HCLC and two different layers. So now we are going to discuss about the different standards of Ethernet. Okay, the original Ethernet was created in the year of 1976 at SRAX, Palo Alto Research Center, PARC Research Center. There they are created this Ethernet. So according to the speed, it will be classified like standard Ethernet, fast Ethernet, gigabit Ethernet, 10 gigabit Ethernet. Okay. So how we can say the speed in 10 Mbps speed means that is the standard Ethernet. So 10 times of standard Ethernet. So that is fast Ethernet, 10 times faster than standard Ethernet. So this one is 10 times faster than fast Ethernet, 10 times faster than fast Ethernet. So that's why we can say 1 gigabit Ethernet. Okay. So this is faster than 10 times faster than 10 gigabit Ethernet. Okay. So gigabit Ethernet 10 times faster than gigabit Ethernet. So according to the speed, we can classify that our evolution of the Ethernet have happened. So 802.3 I told already. 802.3 means it's a wired local area network. Okay, so these standards will be considered the wired network. So MAC frames, media access control frame, how it will be there. You just remember these frames, whatever it is there. Okay, so preamble and start frame delimiter, destination address, source address, length or type of the data, and data finally CRC will be there. Okay, so how it will be represented initially? So in the physical layer, the device may be connected to another device. Okay, so how it will identify the data is transmitted? Initially, it will send 56 bits, ones and zeros, 1 0 1 0 1 0 1 0, like that it will send. Okay, so after 56 bits, then it will send the data like 101011. So whenever it is getting 10, this frame, that is this byte, the destination understand that next bit may be represent the destination address. Okay, the destination address will be represented with the 6 bytes. Okay, just remember those things. And Ethernet does not provide any mechanism for acknowledgement. Okay, so if any frames are received or not, for that there is no acknowledgement mechanism in the Ethernet. It is only the layer control or access control will be there. So what is preamble? I told 56 bits, like 7 bytes of data. So 7 into 8 bits. So 56 bits, alternate zeros and ones will be sent for synchronize the session. So sender and receiver. Okay. So once 56 bits over, then it will send the delimiter. What is the delimiter? Delimiter have 1 byte. So 7 for preamble plus 1 for delimiter. So this frame, once the destination received 10101011, then destination understand that the next bit will be the represent the destination address. Okay. So length or type of the data. So how the length will be calculated? You just see here the length may be represented using 2 bytes, but the payload length is 46 bytes. Okay, the minimum is 46 bytes, maximum is 1500 bytes. So then how the total bytes will be considered? So 6 bytes for address, 6 bytes for source address, 2 bytes for length, payload data unit, and 4 bytes for CRC. 4 plus 2, 6, 6, 6 plus 6 plus 6, 18 plus 46, 18 plus 46. So the minimum is 64. Okay, 64 bytes. What is the maximum bytes? So same 18 plus 1500. Okay, 1500 bytes. So totally 1580 bytes is the maximum length of the data. So normally we discussed many times in data link layer we are using the MAC address. So what are the things we can say that this is the MAC address means it is the permanent address. I already told permanent address, or we can say the MAC address, media access control address, or uh, or uh, this is for link layer control address. So anything we can say about it. How it will be represented when the Ethernet is connected to the network, the NIC network interface card is there. No, in that card this address will be printed. What is this address? This address will be represented as MAC address. Okay, so this will be represented with this 6 bytes. How they are representing? So already we know that how to represent the MAC address. Anyway, I will explain here. Okay, so totally 6 bytes. So 6 bytes means each byte here 1, 2, 3, 4, 5, 6. So each byte have 8 bits. Okay, so 8 bits. So 6 into 8 bits. So totally 48 bits will be there. Okay, so it will be represented 48 bits. Then each byte have hexadecimal number. How we can represent the hexadecimal number? Hexadecimal number, it will occupy 4 digits. Okay, 0002 F F F F. So this is the hexadecimal number we know. So the individual digit will represent 4 digits. So 4 plus 4, 8 digit will represent each bytes. Okay, so that's why 12 hexadecimal number. 6 bytes are there. Each byte have 6 bytes are there, and each byte have 2 hexadecimal numbers. So 6 into 2, 12 hexadecimal numbers we are using for represent the MAC address. Okay. So in the address itself, we can consider which type of address. So we know that unicasting, multicasting, and broadcasting. Okay, unicasting means one-to-one communication. Multicasting means one-to-group communication. Broadcasting means many-to-many communications. That one to many communications. So how we can represent that after converting into the binary value, the first byte last value will be shows that it is unicasting or multicasting. If the last bit value is 0 means that is unicasting. If last bit is 1 means that is multicasting. Okay. So total 6 bytes are there. The first byte last bit we have to consider. If the bit value is 0, that is unicasting address. The bit value is 1, that is multicasting address. You just remember this. Okay. So now the reflection point is there. I given 3 address. You just identify which type of address are there. 10 seconds I given time. Thank you. So what is the solution of this? We have to identify second uh, in the first byte last number we have to identify. What is the A value? A is 10 value 1010. The bit is 0, then you can say that it is unicasting address. Okay. So first address is unicasting address. Second address 7 is there. What is the value? 70111. So the last bit is 1. So it is multicasting addresses. Okay. So then all the values are F. That is 1 means it is broadcasting values. You just remember that. Okay. So that is we are given solutions. So the address is sent left to right, byte by byte. For each byte is sent right to left, bit to bit as shown below. So first what we have to do, we have to convert into binary values each byte. Then each byte will shift it to left to right shift. Okay, so the if in case how we can write 47, 47 means the value. What is the value? 1000. Sorry, 0100. Okay, so here this is correct or not? We can say 4214. So 0100. This is first 4 values. 7 values means 0111. So how we can represent this? The first value will go this side, then this will be goes to last. Okay, so then 1110, then 0010. Okay, so I am just shifting the first byte. So after shifting, I am getting this value. Same like that. This second byte. Okay. So this is third byte. This is fourth byte. This is fifth byte. This is the last byte. Okay. So 6 bytes. After converting the binary value, it will be shifted. So now we came to uh, discuss about cable. Which type of cable we are using in the Ethernet standard. So there is a 4 type of cables are there. We can represent that implementations of Ethernet. So 10 is 10 Mbps speed. We already know standard Ethernet is represent 10 Mbps speed. Okay. Here base means baseband signal. So broadband signals, baseband signals, 2 types of signal is there. But in the Ethernet we are using only baseband signal. So what is 5? 5 is represent the length of the cable. So what is this? Thick coaxial cable they are using. 5 means 500 meter will take it. Okay, so 2 means 200-meter maximum. It will represent 185 meters. Okay, so in thin coaxial cables. So T means twisted pair cables. F means fiber cables. Okay, so unshielded twisted pair cables they are used. So the topology used as first topology for these two, like coaxial cables, are twisted pair cables or fiber cables. They are using star topology. Okay, so we just remember these things. In standard Ethernet, we are using the Manchester coding. So already we know that Manchester coding encoder techniques. Okay, so 0 means positive to negative, 1 means negative to positive. So this code we are used for standard Ethernet. Okay. So now 10 base 5. What is 10 base 5? I already told 10 Mbps speed, baseband signals, 500-meter length. Okay. So this used as the bus topology. So bus topology already we know. Okay. So the tape connection is there. Common cable will be there. They are using the taping. Okay. So based on that taping, you can use that maximum 50-meter taping connection may be there. Okay, the maximum length is 500-meter, and each tapping will take 550 meters. If more than that, if you are using it, the signal may be affected. Okay. So this is base 2. So 2 means 200. So normally the 200 means 185 meters. So what is this? This is the thin Ethernet cable. Okay. So thin Ethernet means it is flexible to bend it. It is not damaged. Okay. So very close to the station it will connect. There is wherever the stations are there, immediately it will connect. Okay. So here there is no previous method 50 meters cable we can use, but here not like that. Wherever the stations are there, the cable will bend to the nearest to the stations. Okay. So if system is there means it will go up to the system, it will take the connection from there. So what is the maximum length? Maximum length is 185 meter. So you just remember that there they are using the coaxial cable as well as bus topology. So these two techniques we are using bus topology only. So now we are going to third method, twisted pair Ethernet. So we can represent that 10 Mbps speed baseband transmission and twisted pair cables, unshielded twisted pair cables they are used. Okay. So how it will create it? Two pair of twisted cables. So twisted pair cable means two pair of cables create two paths, one for sending, another for receiving. So two cables will be used between the station and the hub. So one is for sending the data, another one is for receiving the data. You just remember it. Okay. So what is the maximum length? Actually, the twisted cable here is defined as 100 meter. So maximum you can use 100 meters. If you are using more than 100 meters, there is the attenuation will be there. Okay, so attenuation will be happened. That is transmission impairments will be happened. So this is the twisted pair cable connections. So central server is there. That is sorry, central controller is there. That is means switch or hub we are using. Okay. So this is using the star topology. So wherever the central controller is comes, that it considers the star topology. So then system may be used that maximum 100 meters length of the cable. Okay, so this cable is twisted pair cables. So these are twisted pair cables. Here also they are using baseband signal. The maximum data range is 10 Mbps speed, 10 megabits per second. So finally, fiber cable. Wherever the here also they are using the star topology. They are using the fiber cable. So the hub is connected to two fiber optical cables. Okay, so here you see two fiber optical cables. One is for sending, another one is for receiving. Okay, so now I given 10 seconds time. You just identify 10 base 2 means in 10 base 2, what is 2 means? 2 represent two twisted pair cables, or 200-meter length, or 185-meter length, or two type of wires. Which is answer? Good. So the answer is 185-meter length. Normally, the 2 is represent 200-meter, but in the thin coaxial cable, we are using maximum 185-meter length. Okay. So if you are not able to identify the proper answer, again you will visit this previous slides, then you continue with this answer. Okay. So this summary of this video lecture. So we know that the four type of standard Ethernet we are discussed: 10 base 5, 10 base 2, 10 base T, and 10 base F. So 5 means 500 meter, T 2 means 200 meter, T means twisted pair cables, F means fiber optical cables. So how many cables we are used? 2 fiber optical cables. Here 2 unshielded cables. Okay. Here only coaxial cables are there. So these two are using bus topology. Okay. So these two are using star topology. So maximum length already we discussed. Okay. So 100 meters and 2000 meters. All the Ethernet standards are using Manchester line encoder encoding and decoding schemes. It is using the Manchester method. Okay. So now we have to revisit the lecture outcomes. Having completed this discussion on Ethernet standards, now students should be able to identify the delay of the data transmission in different types of Ethernet cable. How we can identify the delay? So the cable length, how much length we are used, according to the length, distance by the speed, we can calculate the data delay. Okay. So the formula is how can identify delay equal to distance by speed. Okay. So how much distance? So the distance already we are mentioned. How much? How many meters used for the data? Okay. So in the previous slide, we are used. This is 500 meters. This is 185 meters. This is 100 meters. This is 2000 meters. So this is the distance. Okay. So how the data is transmitted and what speed it is transmitting. Now you just listen, you read the problem carefully. This is based on the learning outcome 1. Okay. So here use proper Ethernet cable for forming a network. Here what we have to do, we have to identify the delay. So how much time it will take to reach from beginning to end of the network. So here what they are saying, they are using 10 base 5. That means what is the meaning of that? 10 Mbps speed data, baseband transmission, 500 meter length. Maximum is 500 meter length. What is the 2000 meter? 2000 meter means first one device will be there, one 500, one wire will be there, then second wire will be there, then third wire will be there, then fourth wire will be there. So here 500, 500, 500, 500. Then how many devices in between there? 1, 2, 3. Okay. So what they are saying that assume there is 10 microsecond delay in equipment. So here 10 microsecond, here 10 microsecond, here 10 microsecond. So totally 30 microseconds for equipment. Then we have to calculate how much data transmission delay. So how we can calculate distance by speed. So 2000 meter by 2 into 10 power 8. It's a light speed. We know that already. So what is the answer? So delay equal to 2 into 10 power 3 by 2 into 10 power 8. So 2 cancel. So here 1 by 10 power 5 is there. So what is the answer? 10 power minus 5. Okay. So what we know that in case we want to represent these values in microseconds, means how we can do it, we can multiply with 10 by 10. Okay. So what is the answer you will get? 10 microseconds. Okay. So here 10 microseconds we are getting. So total already 30 microsecond, here 10 microsecond, total 10 plus 30, 40 microseconds. It's a data transmission delay. So for further reading and understanding, you can use our textbook by Karuzan, Data Communication Networking 5th edition, and the chapter number 13.3. Also, you refer the weekly tutorials. I hope you are enjoyed this video. Thank you very much.